Hi, and welcome back. So in this lecture, I want to start looking at some applications of properties. And in particular, we're going to start with read-only and computed properties, which are very common scenarios. So to create a read-only property, what does that mean? Well, that just means we need a property where the get method has been defined, but the set has not. So that would constitute a read-only property. Now we have to be careful, of course, because if the read-only property uses a backing variable, let's say the property is language, and then we use a backing variable underscore language, self.underscore language, then of course our users can still modify the underscore attribute because it's a bare attribute. There's no such thing as private attributes. They can still modify that directly. Now, of course, we use that convention of that leading underscore to indicate to users of our class that, hey, this is a variable that I'm using inside my class. Please don't touch it. Don't modify it. Don't do anything with it because it's private. It's part of my implementation details. You shouldn't be touching it. Now, Python is flexible, so it actually does allow people to do it. And sometimes it can be useful, right? If you know exactly what you're doing, maybe you're the one who wrote the class and you want to access it directly. There might be a good reason for that. But in general, you shouldn't be accessing from outside the class. You shouldn't be accessing these underscore attributes directly. If you do and something breaks, that's your fault, your problem, not the person who wrote the class. So don't go complain. Now, another place where these properties are really useful is for computed properties. Let's take a look at an example. Let's say I've got a circle class, and in my init, I specify the radius of the circle, and I'm going to use a bare attribute here, self.r equals r. Now I'm defining a method. So this is this area function that's going to be called as a bound method, and it's going to return pi times r squared, whatever the self.r is. So now when I call this code, I can basically create an instance of a circle with radius 1. I can now call the method area, and it will return the value 3.14. So that's great. But here's another way we can do that as well. Instead of using just the method area, we decorate it with the @property decorator. So now what happens, that's the only piece of code that changed. Now the only difference is that we don't have to call area as a method. It's basically a property, but it's a calculated property, and it returns 3.14. Now, to me, that feels more natural because the area of a circle is really a property of a circle. It shouldn't be a function that I have to call on the circle, right? It makes more sense that area is just a property. Now, in this case, it happens to be a property that I'm calculating every time I request it. So every time I call c.area, it's going to run this method, calculate the area, and return it. So now we can take this one step further. So using property setters is sometimes useful for controlling how other computed properties are cached. So let's look at our circle class again. Now the area was a computed property. And in fact, it was a lazy computation because we only calculate the area when it's requested. The problem is that every time we ask for the area, it's going to have to recalculate it. So it would be nice if we could cache the value. So if it's re-requested, we can use that cached value so we can save the computation time. But what happens if somebody changes the radius? Well, we need to make sure that if somebody's changed the radius, we know about it, and then we can recalculate the area at that point when it's requested. So we need to be able to invalidate the cache whenever the radius is changed. So we can control setting the radius using a property. So instead of having a bare attribute, we now are going to use a property. We're going to use a function so that when we set the radius, right, when the user of our class sets the radius to a value, we'll know that the radius changed, and we can then take some action. So we're aware that the property has changed. So let's try it. Let's try again our class circle. So we're going to again pass in the radius, but now I'm going to use a private attribute to store the radius. And I'm also going to create a private attribute called area, which is going to be where I'm going to cache the value of area for that particular radius. And initially, I'm going to set it to none. I could calculate the area right off the bat here, but if somebody creates thousands of circles and never requests the area, there's no point in doing that calculation up front. I really want to be as lazy as possible about it. So I'm just going to set the area cache to none, and then later, if somebody asks for the area, then I'll go and calculate it. Now I create a property, so this is now the getter for radius, and all it's going to do is just return self._r. So nothing fancy there. But for the setter, I'm going to do a few things. First of all, I'm going to make sure that you cannot set a radius that is less than 0. So I'm going to go ahead and raise a value error if r is less than 0. Then I'm going to store r in _r. Okay, so here the other main thing is I've invalidated the cache. As soon as the radius changes, I make my area none, my underscore area none. Now I create a read-only property for the area. So look what happens. I check when area is called as a bound method, right? It's a property. If it's none, that means that I need to calculate the area. So now I calculate the area and I store it in my cache, in my underscore area. And then I return underscore area. If area already had a value, if it was not none, then I would bypass recalculating the area and just return whatever was in the cache. So this is a lazy evaluation. It doesn't calculate area until it's actually requested. And then for subsequent calls to area, to the area property, if the radius hasn't changed, it doesn't have to recompute the area. It just uses the underscore area cache. So this is a very common use case for properties. All right, so let's switch to some code and let's try all this out. Thanks for watching, and I'll see you in a bit.